Hi guys, welcome back to my channel, and this is nelmark Gado. For today's video, let's talk about work, power, and energy. In everyday language, the term energy is used to imply vitality, vigor, strength, and power. Expressions like, he is full of energy, this food is high in energy, and the energy crisis is upon us, are quite common. In science, we speak of forms of energy, conservation of energy, and transformation of energy. They will be discussed in this video, but we will start with the most common manifestation of energy, work. After watching this video, you should be able to define work and units of work, solve problems on work and power, differentiate work from power, and distinguish the different forms of energy. Okay, work. In science, work is accomplished if a force is able to move an object. You may exert a force on an object, but if the object does not move, you have not done any work. If you push a wall with all your strength but the wall does not move, you are not doing any work. If a body is moving and there is no force acting on it, then no work is done either. The formula for work is force times distance in the direction of the force. In symbols, we have W is equal to F times D. If force is in newtons and distance is in meters, then work is in joules. That is 1 joule is equal to 1 newton times 1 meter. Then 1 joule is equal to 1 newton meter. Or, take note that we know that 1 newton is 1 kilogram meter per second squared. Then, another unit, 1 joule is equal to 1 kilogram meter per second squared times meter, or 1 kilogram meter squared per second squared. Illustration of work. Letter A, work is done on a load by a force through a distance d. Example, a load is moved 5 meters by a force of 10 newtons exerted parallel to the direction of motion of the load. Find the work done. So given our force, which is 10 newtons, and distance, which is 5 meters. So we're asking for work done. Formula, work is equal to force times distance. Then let us plug in those two values. We have 10 newtons for force, then distance 5 meters, and get the product. So we have 50 newton meters or 50 joules. Take note that 1 joule is equal to 1 newton meter. And this is the final answer. In case letter B, if the force is not in the direction through which the load moves, then we must get the component parallel to the direction of motion. So we have here, we know that in right triangle, in this case, the force is acting hypotenuse. And we have theta, okay? And here, the direction through which the load moves, we have here the adjacent side, okay, which is F cosine theta. So we have here theta and F cosine theta, and the distance denoted by D. Okay, again, when the force is not in the direction the load moves. Okay, when the force is not in the direction the load moves, then the work done by the force is work is equal to F cosine theta times D. Example, a boy pulls a load with a force of 100 newtons through a distance of 20 meters. The rope attached to the load makes an angle of 45 degrees with the horizontal. How much work is done? So given, force is equal to 100 newtons, theta or angle 45 degrees, distance 20 meters. Formula, work is equal to F cosine theta times D. And plug in these values. You have 100 cosine 45 degrees times 20. And work is equal to 1414.21 joules. Case letter C. If an object is lifted above the ground, the force is needed to move. It is equal to the weight of the object. The work done in this case equals weight, which is mg, weight, which is mg, times the vertical distance, h. In symbols, work is equal to weight times height, or since weight is equal to mg, work is equal to mgh, mass, gravity, and height. Example, a man lifted a 50 kilogram sack of rice to the back of a truck 1.25 meters above the ground. How much work was done? Solution, work is equal to weight, work, para di tayo malito, no? Lagyan natin ng sub K, stands for work. That is equal to weight times height. Okay, and we know work is equal to mass times gravity. Okay, and times height. The given mass is 50 kilograms times gravity, which is 9.8 meter per second squared, times 1.25 meters. So the answer is, get the product. So the product is 612.5 kilogram meter squared per second squared, or 612.5 joules. Okay, for now, let's talk about power. If two men each carried a 50 kilogram sack of rice to the second floor of the house, then they performed the same amount of work. But if one did it in 2 minutes and the other in 4 minutes, then we say that the first man had more power than the second. Power takes into account the time taken to do the work. It is defined as the rate of doing work, or power is equal to work over time. In symbols, we have P is equal to W over T. If work is in joules and time is in seconds, then power is in watts. 1 watt is equal to 1 joule per second. A larger unit of kilowatt equals 1000 watt. That is 1 kilowatt is equal to 1000 watts. Example, a force of 30 newtons was applied in dragging chair in a horizontal frictionless floor through a distance of 10 meters for 3 seconds. What is the value of power in watts? So solution, formula power. Power is equal to work over time. And based on the given, we don't have the value for the work. And we need to solve for work. And we know that work is equal to force times distance and over time. And force is equal to 30 newtons times 10 meters over 3 seconds. 100 Nm over S or 100 joules per second or 100 watts. Example, a 100-watt light bulb was installed in physics lab. Determine the amount of energy in terms of joules it uses per hour. So 100 watts is equal to 100 joules per second. So ang goal lang natin dito is i-convert lang ito, 100 joules per second to joules per hour. Okay? Yun lang yung goal natin, i-convert natin. Yun lang kasi yung sinasabi, o yun lang yung pinapahanap dun sa question. And take note, 1 hour is equal to 3,600 seconds. Okay? So, ang gagawin natin, ko-convert natin siya in terms of joules per hour. So, 100 joules per second times, okay, 3,600 seconds over 1 hour. Okay. Same lang sila, no? This is equal. So, kung same sila, that is equal to 1. So, this part is equal to 1. And 1 times joule per second is still hindi magbabago yung ating given. Okay? So, ang goal lang natin dito ay i-convert natin siya. So, cancel to second. Okay? Then, kunin natin yung product ng 100 tsaka 3,600. We have 360,000 joules per hour. And that's it. And now, let's talk about energy. When a carabao does work by pulling a load, it has energy. When a boy carries his bag of books to school, he has energy. When the cover of a cooking utensil is lifted up by boiling rice, then the heat responsible for the action has energy. In short, work is evidence of the presence of energy. And energy can be simply defined as the ability to do a work. The units of energy are the same with the units of work. We have forms of energy. Number 1, potential energy, or PE. Energy possessed by an object because of its position. Potential energy is equal to weight times distance. W here is for weight. D is for distance, length, or height. Also, we have gravitational potential energy, or GPE. Energy possessed by an object because of its position relative to Earth. GPE is equal to mass times gravity times height. Also, we have EPE is equal to 1/2 kx squared, where k here is force over x, that is force constant of the spring. X is the length or distance of elongation or compression. Number 2, we have kinetic energy, or KE. Energy possessed by an object at motion. Kinetic energy is equal to 1/2 mv squared, where m is mass and v is for velocity. And number 3, rest energy, E sub O. E sub O is equal to mc squared, where c is speed of light, which is 3 times 10 raised to 8 meters per second. Example, What is the potential energy of a 2.1 pound stone hoisted at the window of a building 38 feet high? Solution, potential energy is equal to weight times height. Weight is 2.1 pounds. Height is 38 feet. Wala tayong problema sa unit kasi pareho silang FPS system. So get the product, 2.1 times 38, we have 79.8 foot-pounds. Number 2, calculate the kinetic energy of a 1,200 kilogram car which is moving at 40 kilometers per hour. Solution, so mapansin nyo doon sa given natin, we have mass which is 1,200 kilograms and yung velocity is 40 kilometers per hour. So kung itutugma natin yung unit ng mass tsaka velocity ay hindi sila magka-relate, no? Kung in terms of joules ang magiging sagot. So kapag joule kasi, that is 1 kilogram, 1 joule is equal to 1 kilogram meter squared per second squared. So ang goal natin dito sa velocity, yung 40 kilometers per hour ay ko-convert muna natin siya in terms of meters per second. Okay? So multiply natin siya sa, alam natin na yung 1 hour, okay, dito ko siya ilalagay sa taas kasi para makancel yung unit ng R. 1 hour is equal to 3,600 seconds. Okay, isa pa. Times, ang goal naman natin is ma-convert natin yung kilometer sa meter. So dito ko ilalagay yung kilometer para makancel yan mamaya. 1 kilometer is equal to 1,000 meters. Okay? So cancel na itong unit ng kilometers, then cancel na itong R. So we have matitira, meters per second matitira. Okay? So kunin natin yung product, 40 times 1,000 is 40,000 divided by 3,600 seconds. So we have velocity here is 100 over 9 meters per second na siya. Okay? 11.11 dot. Repeating yung 1 tsaka non-terminating. Okay. So, ang ginamit ko na lang, so fraction na lang, no? Kinuha siya as fraction. 100 over 9 meters per second para sa velocity. Okay, so hinahanap yung kinetic energy. Kinetic energy is equal to 1/2 mv squared. Okay. So 1/2 of mass is 1,200 kilograms times 100 over 9 ms squared. Yan. So velocity na. So kunin nyo yung square nyo muna to, tapos times 1,200 divided by 2. Kinetic energy is equal to 74,076 joules. Number 3, determine the rest energy of an object with a mass of 15 grams. So solution, E sub O is equal to mc squared. Alright. And what are the given? Mass is equal to 15 grams. And that's it. Okay. And C, we have 3 times 10 raised to 8 meters per second. Speed of light. Okay, take note that the unit in mass we have is in terms of grams. So we need to convert it first to kilograms. Okay. And take note, 1,000 grams is equal to 1 kilogram. So to convert this to kilogram, 15 divided by 1000 is equal to 0.015 kilogram. Then let's plug in the equation, in the formula, E sub O is equal to mc squared. So we have 0.015 kilogram times 3 times 10 raised to 8 meter per second squared is equal to 4,500,000 joules. And that's all for today's video. Thank you for watching. If you like my video, don't forget to like and subscribe my channel. Thank you.